Welcome to a quantitative aptitude video on chain rule from careerright.com. The problems on chain rule are extremely important for placement test, bank, MBA and all other entrance exams. In every exam you can definitely find at least one or two chain rule sums, and since they are easy, they are very useful to increase your scores. In this video we are going to show you some very easy tricks to quickly solve all questions from this topic. After this video, you can go to careerright.com, which has 1000 plus practice questions on quantitative aptitude, and take the practice test over there. Let's get started. Question number 1. 40 boys paint a house in 96 days by working 9 hours per day. How many hours per day 48 boys need to work so they can paint the house in 45 days? This is a very easy sum if you know the formula. So let's now derive the formula so that it becomes very easy to recollect it in exam as well as remember it in exam. Now, always remember that in chain rule there are always two scenarios. There's the first scenario, then there's the second scenario, and we just need to equate them. Okay, let's see what the first case is. 40 boys paint a house. That means now we know that there are 40 boys. Okay, in 96 days. So they take 96 days to paint a house by working 9 hours per day. So every day they are working for 9 hours, right? Now what is the next sentence? How many hours per day 48 boys need to work? Now earlier we had 40 boys. So what would be the second scenario? Here we have 48 boys. Okay. Now need to work so they can paint the house in 45 days. Earlier we had 96 days. Now we have 45 days. Now how many? Earlier there was 9 hours per day. Do we know how many hours per day? No, we do not know. We have to find out. So let us assume question mark over here, right? There's only one thing missing in this, and that is nothing but the work done, right? Now whenever we are painting a house or constructing a house or cleaning a pool, building a tank, etc., we cannot quantify the work done. Now we can say that I have developed like say 10 missiles, or I have made 100 beads, or I have drawn 1000 sketches or something like that. These are quantifiable things, but building a house, painting a house, etc., this cannot be quantified. So always whenever there is such a scenario that you cannot quantify a work done, you should always take it as 1. Okay, so painting a house, constructing a house, cleaning a swimming pool, the work done would always be 1. So in the first scenario, work done would be W1, and that is they paint the house from scratch, so that is nothing but 1. Again, in the second scenario, the work done is painting the house, same, they paint the house right from scratch, so the work done is 1. Now, the only slight twist in this formula is that the work done in second case has to be written in the first scenario, while the work done in the first case has to be written in the second scenario, right? It's just the opposite. So work done in the second case, that is W2, will come over here. Let's write 1 over here. And work done in the first case, that is W1, would come over here. So let's write 1 over here because W1 is 1. So this is W1, this is W2. Now we just need to equate these two, right? And now multiply the left hand side values with each other, multiply the right hand side values with each other, over. This is the formula. Let's solve it. 9 5s are 48, 2s are 5, 8s are. So what we get is question mark equal to 8 into 2 equal to 16 hours. So 48 boys take 45 days, okay, to paint the house if they work 16 hours per day. Did you get it? So 16 hours is the answer. See how easy it was. What we did was we had men, we had days, we had time, we had the work done. We had men, we had days, we had time, we had the work done. But work done in first case is on the right hand side. Work done on second case is on the left hand side, and we just multiplied and equated them. Just multiply and equate them. This is the formula for chain rule. There's nothing else to it. You just need to multiply and equate. Multiply and equate. Okay, let's take a look at the formula for chain rule in a better manner. Chain rule formula. Whenever they have given number of men, number of days, amount of time, hours, amount of work done, then we simply have to multiply men into days into time into work done in the second case, and equate it with men into days into time into work done in first case. Remember, work done in the second case is on the left hand side, work done in the first case is on the right hand side. We just need to multiply. 2 is over here, 1 is over here. Rest all the stuff is like that, 1, 1, 1 and 2, 2, 2. So in chain rule, we just have to multiply men into days into time into work done in second case. That would be equal to men into days into time into work done into first case. Let's see how to use this to solve further sums. Question number 2. 54 toy makers can prepare 36 toys per day. Ajay wants 416 toys. How many toy makers should he employ to get the job done in 16 days? Now again, this is very easy. We have our two scenarios which we need to include, which we need to equate. Okay, we have our men, we have days, we have time, we have work done in second case. That is equal to men into days into time into work done in first case. Let's find out both the scenarios. Now, case 1, number of men would be 54 toy makers, right? How much is the number of days? Let's see. 54 toy makers can prepare 36 toys per day. So number of days would be 1. Okay. Now time is not given over here in both the cases, so need not consider time over here. Okay, we'll simply neglect time. Now work done. What they have given, they prepare 36 toys per day. What is this? Preparing 36 toys is quantifying the work, that is nothing but work done. Work done in first case. Where will it come? It would come over here. So let's write 36 over here. Okay. Ajay wants 416 toys. 416. What does it mean? It is nothing but work done in second case. So that would come over here. So let's write 416 over here equal to number of men in second case. Let's find out. How many toy makers should he employ? So we do not know number of men in second case. So there's a question mark. Now number of days. Should he employ to get the job done in 16 days? So number of days in second scenario is 16. So let's solve this. 9 4s are 9 6s are, okay, 16 2s are 32. So we have 8 9 96 16 6s are 2 2s are 2 into 13 2 into 3. So question mark would be 13 into 3 39 toy makers. Okay, so 39 toy makers are needed to get the job done in 16 days. See how easy it was. Whenever you will solve in future, you won't even have to write 1 equal to 2, or you won't even have to write the formula. You will simply start writing like 54 into 1 into 416 equal to, and you can solve. This will help you to solve the sums under 30 seconds. Okay. See how easy it was. We just have men, we have days, we have time, we have work done in second case. We equate it with men into days into time into work done in first case. And once you practice, you solve more and more sums, you won't even have to write this formula. You will directly go to this stage and be able to solve sums in 30 to 35 seconds. Let's move on to question number 3. Question number 3. 2,500 children in a school had enough chocolates for 40 days, but some children never came to school and the chocolates lasted for 50 days. How many children never came to school? Again, this is an easy one. We have our two scenarios, right? And we equate them. We have men, we have days, we have time, we have work done in second case. That would be equal to men into days into time into work done in first case. Okay. Now, what is the number of men in first case? That is nothing but number of children. 2,500 children in a school. They have enough chocolates for 40 days. So we write number of days as 40. Do we know the time over here? No. Let's not consider time. Okay. Now work done. Let's see. the work done over here is finishing chocolates, that is eating all the chocolates. Can we quantify this work? Yes, we can if we know the number of chocolates. But do we know the number of chocolates? No, right? Since we do not know the number of chocolates, what we can consider is that this act of finishing a chocolate or eating the chocolates is nothing but 1. Okay, so work done in the first case would be 1. So where do we write the work done in first case? On the right hand side, okay, over here. Again, in the second case, the children who are there, they eat the chocolate, that is they finish the chocolate in 50 days. So the work done would, that is W2 would be nothing but 1. So that we write over here, correct? So W2 is 1. Then we equate. Now, what they say is that some children never came to school, right? So let us assume that M children never came to school. So how many children came to school or were present? 2500 minus M. And what happened was that when these children came to school, they had chocolates for 50 days. Okay. So we have in the second case number of children as 2500 into M. And how many days did the chocolate last for them? It was 50 days. So let's calculate. What do we get over here? 50 into 50. So 2000 equal to 2500 minus M. M would be 500. So 500 children never came to school. So this is the answer. See how quickly we found out the answer. Moving on. Question number 4. 4 women and 4 children start working together. How many days will they need to paint a house completely if 3 women alone can paint the house in 18 days and 6 children too alone can do the same in 18 days? Now what they have given is that 3 women can paint a house in 18 days, okay, and 6 children can paint the house again in same 18 days. So what we can say over here is that 1 woman is equal to 2 children, right? That means the amount of work done by 2 children is same as the amount of work done by 1 woman, because 3 women and 6 children, they take the same amount of days. Let us remember this derivation. It is useful later on, okay? Now, again, we have 2 scenarios, right? 1 and 2, and we need to equate. Now, what they have given over here, 4 women and 4 children start working, right? Now, in the second case, we can have 3 women working or 6 children working. Okay, let's go with 6 children working. Let us say 6 children working, and we have to equate. Now we see over here we have children and here we have women and children. Let us have everything in the same unit, either women or children. Let's go with children. So we'll convert everything into children. So 4 women would be nothing but 8 children. Why? 1 woman is 2 children from here. So 4 women would be 8 children, plus adding these 4 children, we'll get 12 children, and in this case we have 6. Okay, so again I am writing the 2 scenarios over here. We'll have 12 children. Okay, for how many days are they working? We do not know. Okay, what the formula is, you know, MDTW and MDTW1. Men we know 12C, number of days we do not know yet, time is not given, don't consider. Work done. What is the work done? Painting a house. We saw painting a house means take the work as 1. So in second case the work done is 1 equal to in the first case. Now here we have taken 6 children. You can take 3 women also. There is no problem at all. But here we are considering the situation of 6 children. So there are 6 children. They take 18 days to paint the house, and time is not given, and the work done is nothing but 1. Let's calculate. This becomes 2, 2, 9. So it is 9 days. So when 4 women and 4 children start working, they take 9 days to complete the house. See how very quickly you can solve this sum using this basic formula. Just multiply and equate. Going to the next question. Question number 5. 12 pumps of one type pump 30 liters of water when each is running for 18 hours per day. But a set of 16 pumps of other type pump 40 liters of water when each is running for 24 hours per day. How efficient are former type of pumps than the latter type? Again, here there would be two scenarios, like since it is a chain rule sum, we'll have your R, M, D, T, W. M is nothing but the type of pumps, the number of pumps over here. Of the first type, of one type, we have 12 pumps, and the days taken, it is not given, so don't consider days. Then time it is 18 hours per day for the first pump, so right, 18 into work done in second case. Now we do not know the work done, let's see what it is. 12 pumps pump 30 liters of water. So this 30 liters of water is nothing but work done, okay, because we are able to quantify it. So 30 liters of water is the work done in first case, so that would come over here in the second scenario, okay. Now each is running for 18 hours per day, that we have included, but a set of 16 pumps of other types. So number of men in second case would be 16, that is the number of pumps, right. Other type pump 40 liters of water. What is this 40 liters of water? Work done in second case, that would come over here. So write 40 over here, equate it. Now we do not know number of days over here. What is the time for the second scenario? 40 liters of water when each is running for 24 hours per day. So write 24 over here. Okay, now over here you can see nothing is missing. All the values are given. Then what exactly do we have to find? We actually have to find efficiency. What is efficiency, or what is being efficient? Let us say that A is twice as efficient as B. That means that A will do, in the same amount of time, A will do 2 times more work than B. If A is 5 times more efficient than B, then A, in the same amount of time, say 1 hour or 2 hours or something like that, A will do 5 times more work than B, if A is 5 times more efficient than B, okay. Now over here what we have to find out is how efficient is former type of pump than latter type, okay. So we cannot have, that means that there are two different types of pump, okay. There are two different types of pump, one is former type, one is latter type. So over here whatever we have written 12 and 16, we cannot write it directly. It is like there are two types of fruits, one is apple and one is orange, okay. Can we equate apples to oranges, like 16 apples are there and 20 oranges are there, and let's equate it? No, we can never do that, okay. So what we need to have is, there are 12 pumps of former type, okay. So let F denote the pump of former type. So there are 12 pumps of former type into 18 into 40 would be equal to 16 pumps of latter type into 24 into 30. So L represents latter type pump, F represents former type pump, okay. These are like differentiating factors that that differentiate both the type of pumps. So 12F, or the 12 pumps of former type, can be equal to 16 pumps of latter type when these factors are there, okay. So now let's calculate. What do we get over here? 10 3s are 10, 4s are 6, 4s are 6, 3s are 3, 3, okay, 4, 4. So we have 12F equal to 16L. So F upon L equal to 16 by 12 equal to 4 4s are 4, 3s are. So 4 by 3. So the former type of pumps are 4 by 3 times more efficient than latter type of pumps. Why? Over here what we saw, if A is 2 times more efficient than B, then A does 2 times more work than B, right? So what would be A upon B? 2 upon 1, right? Same way over here, F is equal to 12F equal to 16L. So F would be 4 by 3 times of L. So over here, if A is 2B, this means that A is 2 times more efficient than B, then this means former type of pump is 4 by 3 times more efficient than L. See how easily you got the answer, okay. Going to the next one. Question number 6. 75 girls complete 1/3 decoration of a building in 40 hours. Now they have only 50 hours to complete the rest of the decoration. How many more girls are necessary to help them to complete the task? Again, there are two situations and we have our formula MDTW work done in second case equal to MDTW work done in first case. In the first case, we have 75 girls, okay. Now they are taking, now number of days is not given, so let's not consider it, right. They are taking 40 hours, okay. And what is the work done in their case? Let's see. Girls complete 1/3 decoration of a building. Now, what happens over here is like painting a house. Decorating a building from scratch means like painting the house. So work done should be taken as 1, correct? So 1/3 decoration of the building is over. That means 1/3 work is done, right? So where will this 1/3 come? Over here, because this is the work done in first scenario. Now, if 1/3 decoration is done and the sum says that find out the how many girls are necessary to complete the task or the rest of the decoration, that means remaining amount of decoration is nothing but this, rest of the decoration is nothing but work done in second case. Let's find out how much decoration is remaining. If 1/3 is done, how much is remaining? 1 minus 1 by 3 is 2 by 3. So this is nothing but work done in second case. Let's write it over here. Why? Because work done in second case always comes into the area of first scenario, okay, as per this formula. Now, number of men in second case, we do not know. Now, there were initially 75 girls and they say find out how many more girls are necessary to complete the task. Let us assume that G more girls are necessary. So now in second scenario, how many girls are working on decorating the building? 75 plus G, right? Because G girls get added. So in second scenario, amount of girls is 75 plus G. Now they have only 50 hours to complete the rest of the decoration. That is given in the second sentence. Okay, 50 hours. So work done, the time taken in second scenario is 50. Let's calculate this. We have all the values over here. This is 5. This is 4. This is 5 ones are 5 15s are. Okay. We have 15 into 4 is 62, 120 equal to 75 plus G would be equal to 45. So 45 more girls are needed, right, to complete the task. Moving on. Question number 7. Rohan wants to build a tank in 20 days, for which he hires 60 workers. After 10 days, he sees that only 30% of work has been done. To speed up the process and get the tank built in stipulated time, how many workers should work on the tank? Again, pretty easy sum. We have the two scenarios over here. We have men days time work done. So in the first case, number of men would be 60, right? Then days is given. So Rohan wants to build the tank in 20 days, but this is the entire time limit. What he says is that after 10 days, that means 60 workers, when they are working for 10 days, he sees that only 30% work has been done. Okay, so to speed up the process and get the remaining large amount of work, that is 70% work to be done, how many workers should work on the tank? That is asked. That means he must have put in some workers or removed some workers and made sure that the work gets completed in these 20 days. So these 60 workers must have worked only for 10 days. So in the first scenario, the number of days would be 10. Because corresponding to men, we have to find the number of days. It is not what is given in the numerical directly. So these 60 workers work for 10 days. Now the time, do we know time? No. So don't consider time over here. Now work done in second scenario, we do not know. Let's leave it blank. Okay. Now work done in second case. Now we are asked how many workers should work on the tank to complete the remaining work. Okay. So we do not know that. Let us assume that n number of workers should work, multiplied by number of days. Now already 10 days have passed. 60 workers worked for 10 days. So how many days are remaining? Only 10 days are remaining, because we have to build the tank in stipulated time. So 10 days. And what is the work done? We do not know in first case. Now let's find out what is the work done. Say a tank is being built. Okay. Out of that 30% work is done. What is 30%? 30 upon 100. That is nothing but 3 upon 10, right? This much work is done. So how much is the remaining work? This is done. This is nothing but work done in first case, right? Because 60 workers in 10 days did 30% work, that is 3 by 10. This is work done in first case. Where will it come? It will simply come over here. Let's write it. Now, how much work is remaining? 30% is done. 100 minus 30% is 70%. So 70% is remaining. 70% is 70 upon 100. That is nothing but 7 by 10. This is the amount of work left. What is this? Work done in second case, right? So where will it come? Over here. Let's calculate. We get m equal to 3. So this 3, this 7, 7 6 are 420 divided by 3 equal to 140. So 140 men are needed for Rohan to complete the remaining work in the remaining 10 days, so that the tank gets built in 20 days. Remember, it is not asked how many more workers are needed. If they ask how many more workers are needed, it would be simply 140 minus 60 equal to 80 more workers are needed. But this has not been asked. What is asked? How many workers should work? That is the total men that should work. So answer is 140. Going to the last question. Question number 8. A tank has oxygen for 72 patients and can last for 54 hours for them. If patients reduce their oxygen consumption by 10%, then 90 patients can use this oxygen supply for how many hours? Now over here this might look a little bit tricky or something like which is not a chain rule sum, but if you look carefully, it is a chain rule sum. We have two scenarios over here. Okay, we might not find work done like normally which we have, but here there is another quantity which is similar to work done, and that is nothing but consumption. Okay, now what we can observe over here is that whatever the tank of oxygen is there, okay, that is same for 72 patients and 90 patients. Both of them use the same tank, that is the same tank is used in both scenarios. Okay, now how much of the oxygen has been consumed? How can we find that? We do not know actually. Okay, and what is the capacity of the oxygen over here? That also we do not know, but it is much easier to find consumption. How? Let's see. Let us assume that in 1 hour, one patient breathes P amount of oxygen. In 1 hour, one patient breathes P amount of oxygen. So in 1 hour, 72 patients will breathe how much? 72 P, right? Pretty easy. 1 hour, one patient, P amount of oxygen. 1 hour, 72 patients will breathe 72 P amount of oxygen. Now in 54 hours, how much oxygen will be taken in by 72 patients? 72 P into 54. So first case scenario is 72 P into 54. This is the oxygen consumed in the first case. That is nothing but the capacity of the oxygen, because this gets over in 54 hours when 72 patients breathe. So capacity of the oxygen or the amount of oxygen in the tank is nothing but 72 P into 54, and we know that the capacity of the tank is same for both the cases, right? So we need to equate. Now let's go on to the next case. What is the next case? If the patients reduce their oxygen consumption by 10%, so initially if they were taking in P minus 10%, now they will take, okay, so that would be nothing but 100 minus 10% is 90%. So now they will take 90% of P. Amount of oxygen taken in by one patient would be 90% of P, that is nothing but 90 P upon 100. Is that right? So one patient in 1 hour, one patient will take 90 P upon 100 amount of oxygen in this case, in second case. How much amount of oxygen will be taken in by 90 patients, right? It would be 90 into 90 P upon 100, right? So we'll write 90 into 90 P upon 100. But number of hours, do we know? Here we know 54 hours the patients can take in the oxygen, but this 90 patients in 90 P upon 100 amount of oxygen. So for how many hours can they take? We do not know. So put in a question mark. Let's solve. P gets cancelled over here. Okay. 9s are 10, 9s are, and 10 10s are 100. 9 6s are 9, 8s are, question mark, equal to 8 6s are 48 hours. So 90 patients can breathe in for 48 hours if they reduce their oxygen consumption by 10%. Okay, see how easy it was. You just had to multiply these values and equate it. Chain rule sums are pretty easy. Never leave them for option. Always attempt those. It is pretty easy to score in these sums. If you practice enough, you will be easily able to solve any type of sum related to chain rule. Okay. With this, we have come to the end of this video. If you like this video, please give it a like and share it with your friends. You can leave your comments and suggestions for us in the comments box below. You can tell us about any specific videos that you would like us to develop for you. We would be rolling out more such videos and tutorials, so subscribe to our channel and stay updated.